Hello everybody, welcome to this video on how images work. We'll be defining what images are, we'll be talking about pixels, resolution, RGB, RGBA, different file formats, the difference between JPEG and PNG, etc. This is brought to you by Proximity Cybersecurity. I am Prav, I'm the founder of Proximity, and we try to make cybersecurity accessible to everyone. And computer vision is something we focus on too. So let's get started. So before talking about how images are stored, let's try to define what images are for the people who do not know what it is. Images are essentially pictures that have been converted into an electronic form. We have physical pictures that have been captured by cameras. We need a way for these pictures to be stored, and obviously stored in computers. And for it to be stored in a computer, it should be converted into an electronic form, and we'll talk about how this is done. So how are images stored in computers? Well, when we're talking about the most basic understanding, images are stored with the help of different file formats. We've seen PNG, JPG. We've also seen ICO, GIFs, etc. It is stored as a list. What is a list? List is a collection of elements. And for example, in images, it's going to be a list of numbers in a contiguous memory block, which essentially means a continuous part of memory. For example, it's going to have one block of memory, and this memory block is going to be reserved for that image, and it's not going to cut off in the middle. So we have different file formats, and for example, we have JPEG, we have GIFs, we have PNGs. These are the most commonly used pictures. We know what GIFs are. They're essentially a collection of pictures at a very low frame per second. We have JPEGs, which is essentially Joint Photographic Experts Group. It is it is mainly used for photography, etc. And we have PNG, which is a file format for image compression that was designed to provide a number of improvements over the GIF format. Now, GIF was also kind of used for image compression, but we know how GIFs work. And for example, let's say we need a static image. We obviously need a PNG for that. And in PNGs, usually after image compression, the quality is not lost, but for JPEG it is. And the source for this information is voris.techtarget.com. I highly recommend you to check it out. Now let's talk about pixels. Pixels, so we know what cells are in a human body or in any biological body. It is the smallest unit of any body. The same way pixels are the smallest unit of an image. So if you take an image over here and if you zoom into it as much as possible, we'll be able to see these tiny squares over here, and these squares are called pixels. I'm pretty sure all of you guys know that. And if you break down a picture, you can see that these are just a collection of colors. For example, this is a collection of, let's say, different shades of red or different shades of brown, green, and you have black, right? So this is essentially a pixel, or an image is just a collection of colors. And how are they stored? Pixels are denoted with something called pixel values, and it denotes the value of intensity. These values are converted into numbers and then into binary, because everything in a computer is stored as binary, which is zeros and ones. So these are converted into binary and it is stored as a long list. And we will be taking a look at this practically in Python. So do not worry if you do not understand or if you're not able to visualize what exactly this list looks like. So an image, as I said, is a collection of colors, and we need to know how colors are stored. So let's say we have an image over here. We have a colored image, a dog, and we are dividing this into three different images. So one is the red, one is the green version, and one is the blue version. So all of these colors are stored as different matrices. A matrix or a matrix is essentially just collections of values. It could be a two-dimensional list or a three-dimensional list. So the number of pixels from all the way to the bottom to the top into the number of pixels from left to right. So the width into height is the resolution. And we've seen many types of resolution. For example, 1920 into 1080, 640 into 480, etc. So we have the red matrix, we have the green matrix and the blue matrix, and these have different values. These values can range all the way until 256. It is 256 because each byte can have, or each bit can have two different variations, right, which is zeros and ones, and one byte consists of 8 bits. So 2 to the power of 8 is 256 because we have two combinations and 8 bits, and this ranges all the way until 256. So red can be either 142, the value of red can be 141, 142, 143, for example, and green's value can be 35. So the amount of green, the amount of red, and the amount of blue, all of these can be combined into one matrix, and each color has its own matrix. Now let's talk about the difference between JPEG and PNG. PNG stands for Portable Network Graphics and JPEG stands for Joint Photographic Experts Group. As I said, PNG has lossless compression, which means the picture quality remains almost the same before and after compression, whereas in JPEG, the picture quality is lost after compression. JPEGs are commonly used in digital photography, whereas in PNG, if you don't want the quality to be lost, you will be using a PNG. For example, when you're printing something, you need the exact quality, so we use a PNG. JPEG is used for pictures with complex colors and shading, and PNG supports something called transparency, which is RGBA. A stands for alpha. We saw red, green, and blue over here, but PNG also has something called A, which stands for the intensity or alpha. Now, let's also talk about what the main difference is between JPG and JPEG. Now, it might come out as a surprise for most of you guys, but there's no difference between these two. It's just that in older Windows versions, for example in MS-DOS, it was programmed in such a way that it required only 3-letter extensions, and you cannot extend this value. And then when they started upgrading Windows, they removed this exception. So they changed it to JPEG, which made a lot more sense because it stands for Joint Photographics Experts Group. So that's pretty much it for this video. We spoke about how images work, what resolution is, the difference between PNG and JPG or JPEG. The difference between JPEG and JPG, we learned about all the different, most of the different file formats. There are obviously a lot. There are a lot of write-ups online. You can check that out to understand how images work at a much deeper level. This is just the overview of how images work. This is all you need to start programming software related to computer media. Now, if you don't understand how images work, well, you could still program something, but you won't understand what you're doing, especially if you have to troubleshoot something. It's not going to work out, so please try to understand how images work. I hope you guys enjoyed this video. In the next video, we start programming an image converter, and after that, we will be programming an image encryptor. These are going to be very interesting projects, and you can add this to your resume. So please stay tuned and watch the next few videos, and you will be able to understand images at a much deeper level. But thank you so much for watching, and I'll see you in the next one. Please check out my YouTube channel. If you like it, subscribe, and that's pretty much it. See you.